Today we start method 6. One part of CF is known. General form is d2y upon dx square plus p dy by dx plus qy equal to r. As usual, previous method. The complete solution of the differential equation b y equals to uv. Its complete solution is y equals to uv, where u is one part of CF. Working method: if 1 plus p plus q equals to 0, then its one part of CF is u is equals to e raised to the power x. Second case, 1 minus p plus q equals to 0, then u equals to e raised to the power minus x be a one part of CF. Third, if p plus qx equals to 0, then u equal to x be a one part of CF. If 2 plus 2px plus qx square equal to 0, then u equal to x square be a one part of CF. And the last, 1 plus p upon a plus q upon a square equal to 0, then u equals to e raised to the power ax be a one part of CF. Put the value of u and p in the equation dz by dx plus 2 upon u du by dx plus p into z is equals to r upon u. Here in this equation z is represented by dv by dx. This equation is linear differential equation and solved by linear differential equation method, that is integrating factor e raised to the power integration of p is the 2 upon u du by dx plus p into dx, and its solution is z into integrating factor equal to integration of r upon u into integrating factor into dx plus c. From this equation we find the value of z is equals to dv by dx is equals to 1 upon integrating factor r upon u integrating factor dx plus c. And again integrate both sides, we get the value of v. The complete solution is y equals to uv. To understand this method, taking some examples. First example, t2y upon dx square minus cot x dy by dx minus 1 minus cot x into y is equals to e raised to the power x sin x. Here on comparison, p is equals to minus cot x and q equals to minus 1 minus cot x and r equals to e raised to the power x sin x. Clearly 1 plus p plus q equals to 1 minus cot x minus 1 plus cot x. This term is 0. Therefore, u equal to e raised to the power x be a one part of CF. Now put the value of u and r in the equation dz by dx plus 2 upon u du by dx plus p into z is equals to r upon u. 2 upon u is equals to e raised to the power x, du by dx e raised to the power x का differentiation e raised to the power x, p minus cot x into z is equals to r e raised to the power x sin x, e raised to the power x sin x upon u की जगह e raised to the power x. E raised to the power x, e raised to the power x cancel. Here e raised to the power x, e raised to the power x cancel. dz by dx plus 2 minus cot x into z is equals to sin x, which is linear differential equation. Now its integrating factor is e raised to the power integration of 2 minus cot x dx. Integration of 2, 2x. Integration of cot x, log sin x. On solving we get e raised to the power 2x upon sin x. This is integrating factor. Its solution is z into integrating factor is equals to integration r upon u integrating factor into dx plus c. Z into integrating factor e raised to the power 2x upon sin x is equal to integration r upon u is sin x into integrating factor e raised to the power 2x upon sin x into dx plus c. Sin x cancel, e raised to the power 2x integration of e raised to the power 2x e raised to the power 2x upon 2. Now z is equals to dv by dx and divide by this term sin x upon 2 plus c e raised to the power minus 2x into sin x and integrate both sides. Integration of this term is v integration of sin x minus cos x upon 2, and integration of this term using standard formula we get e raised to the power minus 2x upon 4 plus 1 minus 2 sin x minus cos x plus c1 using this standard formula. This term is v, and the complete solution is y equals to u into v. U is equals to e raised to the power x and v equals to this term. Multiplied both these terms and we get answer first. Now taking another example, d2y upon dx square plus 1 minus cot x dy by dx minus y cot x is equal to sin square x. Here p is equals to 1 minus cot x and q equals to minus cot x and r equal to sin square x. Clearly 1 minus p plus q equals to 1 minus cot x minus cot x equals to 0. Therefore u equal to e raised to the power minus x be a one part of CF. Again put the value in the equation dz by dx plus 2 upon u du by dx plus p into z equals to r upon u. U equals to e raised to the power minus x du by dx minus of e raised to the power minus x p 1 minus cot x and r sin square x upon e raised to the power minus x. On solving minus 2 plus 1 minus 1, this minus cot x as it is into dx. Integrating factor e raised to the power minus x and integration of cot x is log sin x. On solving we get e raised to the power minus x upon sin x. Now z into integrating factor integration of r upon u integrating factor into dx plus c1. Its solution. Z integrating factor is e raised to the power minus x upon sin x is equal to r e raised to the power x sin square x e raised to the power minus x upon sin x into dx. Sin cancel, e raised to the power minus x e raised to the power plus x cancel. Remaining term sin x and integration of sin x is minus cos x. Now to find z. Z equals to dv by dx and divide by this term. We get e raised to the power x cos x sin x plus c1 e raised to the power x sin x. Now dv by dx is equal to 1 minus half e raised to the power minus x into sin 2x multiplied and divided by 2. Multiply and divide by 2, we get 2 sin x cos x is sin 2x and plus c1 e raised to the power x sin x. On integration, again apply formula e raised to the power ax sin bx dx minus half, this term is e raised to the power minus x upon 1 plus 4 minus sin 2x minus 2 cos 2x plus c1 e raised to the power x upon 1 plus 1, that is a square plus b square sin x minus cos x. The complete solution is y equals to uv. Another third example which is very important, 1 minus x square d2y upon dx square plus x dy by dx minus y is equal to x into 1 minus x square raised to the power 3 by 2. First divide by 1 minus x square because the coefficient of d2y upon dx square is 1 in general form. d2y upon dx square plus x upon 1 minus x square dy by dx minus 1 upon 1 minus x square into y equal to x under root 1 minus x square. Here p is equals to x upon 1 minus x square and q equals to minus 1 upon 1 minus x square. Clearly p plus qx equal to 0. Therefore u equal to x be a one part of CF. Now put the value of u and r in equation dz by dx plus 2 upon u du by dx plus p into z is equals to r upon u. dz by dx plus 2 upon u equals to x, du by dx differentiation of x 1 plus b x upon 1 minus x square into z is equals to x under root 1 minus x square upon x. Integrating factor e raised to the power integration of 2 upon x plus x upon 1 minus x square dx. E raised to the power integration of 2 upon x dx into e raised to the power multiplied and divided by 2. So 1 by 2 integration 2x dx upon 1 minus x square. From first integration, this is e raised to the power 2 log x, and second 1 minus x square equals to t, 2x dx equals to dt, and solving we get e raised to the power minus half log 1 minus x square. On solving we get integrating factor x square upon under root 1 minus x square. Now its solution is z into integrating factor equals to r upon u integrating factor into dx plus c1. Z into x square upon under root 1 minus x square equal to integration square root of 1 minus x square upon square root of 1 minus x square dx plus c1. Square root cancel, and x square का integration x cube by 3. Now z is equals to dv by dx and divide by this term x square upon under root 1 minus x square. We get x under root 1 minus x square upon 3 plus c1 under root 1 minus x square upon x square. Integrating both sides, we get v is equals to 1 upon 3 square root of x under root 1 minus x square dx plus c1 integration of under root 1 minus x square upon x square into dx. To solve this integration, put x equals to sin theta and dx equals to cos theta d theta. We get 1 upon 3 integration of sin theta cos square theta d theta plus c1 cos square theta upon sin square theta d theta. In the first integration, put cos theta equals to t and minus sin theta d theta equals to dt. And second integration, cot square theta can be written in the form of cosec square theta minus 1 using identity. First integration of t square, this is t cube by 3, 1 upon 3 already hai, so 1 upon 9 plus c1. Integration of cosec square theta, this is minus cot theta and minus 1 yani theta plus integrating constant c2. Now put t equals to cos theta and theta equals to sin inverse x, cos theta equals to under root 1 minus x square using triangle, and cot theta equals to under root 1 minus x square upon x. We get v is equals to this term, and the complete solution is y equals to u into v. Another important example is x plus 2 d2y upon dx square minus 2x plus 5 dy by dx plus 2y is equals to x plus 1 e raised to the power x. Again divide by x plus 2 because d2y upon dx square coefficient is 1. We get d2y upon dx square minus 2x plus 5 upon x plus 2 dy by dx plus 2 upon x plus 2y is equals to x plus 1 upon x plus 2 e raised to the power x. Here p is equals to minus 2x plus 5 upon x plus 2 and q equals to 2 upon x plus 2 and r equals to x plus 1 upon x plus 2 e raised to the power x. Here 1 upon p1 plus p upon 2 plus q upon 4 is equal to, on solving we get 0. Therefore u equal to e raised to the power 2x be a one part of CF. Apply last method. 1 plus p upon a plus q upon a square equal to 0, u equal to e raised to the power ax. Here a equal to 2. Now put the value of u and r in the equation. Dz by dx plus 2 upon u du by dx plus p into z is equals to r upon u. Dz by dx plus 2 upon e raised to the power 2x dot 2 e raised to the power 2x minus 2x plus 5 upon x plus 2 z is equal to x plus 1 e raised to the power x upon e raised to the power 2x x plus 2. E raised to the power 2x, e raised to the power 2x cancel, and taking LCM we get dz by dx plus 2x plus 3 upon x plus 2z is equals to x plus 1 upon x plus 2 into e raised to the power x upon e raised to the power 2x. Now 3 can be written in the form of 4 minus 1 and 2x plus 4, 2 common, x plus 2 upon x plus 2 minus 1 upon x plus 2 separate कर दें. Remaining term as it is. X plus 2 and x plus 2 cancel. 2 minus 1 upon x plus 2 z is equal to x plus 1 upon x plus 2 e raised to the power x upon e raised to the power 2x. Now integrating factor is e raised to the power integration of 2 minus 1 upon x plus 2 dx. Integration of 2, 2x. Integration of 1 upon x plus 2, that is log x plus 2. On solving we get e raised to the power 2x upon x plus 2. Z into integrating factor e raised to the power 2x upon x plus 2 equal to r upon u x plus 1 x plus 2 e raised to the power x upon e raised to the power 2x into integrating factor e raised to the power 2x upon x plus 2 dx plus c1. E raised to the power 2x and e raised to the power 2x cancel in right hand side. We get e raised to the power x plus 1 upon x plus 2 whole square dx plus c1. Again in numerator term x plus 1 can be written in the form of x plus 2 minus 1. On solving x plus 2 upon x plus 2 square minus 1 upon x plus 2 square. First term 1 upon x plus 2 minus 1 upon x plus 2 whole square dx. Using standard formula e raised to the power x fx plus f dash x dx is equals to e raised to the power x fx. Here fx is 1 upon x plus 2 and f dash x is minus 1 upon x plus 2 ka whole square. Therefore, its integration is e raised to the power x into 1 upon x plus 2 plus c1. Now to find z, z is equals to dv by dx and divide by e raised to the power 2x upon x plus 2. We get e raised to the power minus x plus c1 e raised to the power minus 2x into x plus 2. Integrating both sides, we get v is equals to minus e raised to the power minus x plus c1, or using Euler formula x plus 2 first function as it is, integration of e raised to the power minus 2x, e raised to the power minus 2x upon minus 2 minus differentiation of first one, integration of second e raised to the power minus 2x upon minus 2 dx, and again integration e raised to the power minus 2x upon 4. Now v is equals to e raised to the power minus x after solving minus c1 e raised to the power minus 2x upon 4 2x plus 5 plus c2, and the complete solution is y equals to u into v. Now the next example is x square d2y upon dx square minus 2x 1 plus x dy by dx plus 2 1 plus x into y is equals to x cube. First divide by x square. d2y upon dx square minus 2 upon x 1 plus x dy by dx plus 2 upon x square 1 plus x into y equal to x. P equal to minus 2 upon x 1 plus x, q equals to 2 upon x square 1 plus x, and r equal to x. Clearly p plus qx equals to 0, therefore u equal to x be a one part of CF. Put the value in the equation dz by dx plus 2 upon u equal to x, du by dx differentiation 1 t minus 2 upon x 1 plus x z is equals to r upon u, x or x cancel 1. Here 2 upon x and 2 upon x cancel, remaining term is minus 2z. Integrating factor e raised to the power integration of minus 2 dx, that is e raised to the power minus 2x. Its solution is z into integrating factor is equal to r upon u, that is 1 e raised to the power minus 2x integrating factor into dx plus c1. On solving, z is equal to dv by dx is equal to minus half plus c1 e raised to the power 2x. On integration we get v is equals to minus 1 x by 2 plus c1 e raised to the power 2x upon 2 plus c2, and the complete solution is y equals to u into v. That's complete this method. Thank you.